Hello, everyone. Welcome back to week 9, day 2 for the explain portion of our LS10 B and C lesson with our RPS online lessons. I am Miss Wilson. I'm a life science teacher at Albert Hill, and I've really enjoyed doing a little life science with each of you. So let's go ahead and pick up with LS10, B and C. So on day 1, we watched some videos and we hopefully had a chance to do that optional lab. And I hope you enjoy looking at your river water samples. And today we will explain what LS10 B and C really is. We'll watch a few videos, and then you'll also have a chance to extend your learning with an optional long-term changes virtual lab. And then on day 3, you'll have a chance to evaluate your learning once again with a long-term changes Kahoot and a long-term changes Legends of Learning playlist. So let's get to this explanation for LS10 B and C. If you don't have your student workbook out, you will need that handy. There will be some places for you to take notes as I go through the explanation, as well as we'll look back at your See, Think, and Wonders first that you did on day 1. So let's go ahead and look at that document. And let's look at the See, Think, and Wonders and see what you noted and see if there's anything that you might have thought you saw that you didn't. Okay? So these are the things that we looked at for our See, Think, and Wonder. We looked at the Earth and the two sides image here. And what you should have noticed is that one side of the planet looks a little bit unhealthy. You can see the orange color. It's like it's heat coming off of it. There's no grass. The ground looks dry. You see something burning in the back. And even the tree looks like it's been burned and the fire's coming off the side of the planet. Versus on this side, you can see a beautiful sky, green grass. The planet looks kind of normal and it looks to be in a healthier state. In this picture here, this is the Rucas Fuego. This is actually a picture of a volcano. I hope that you were able to note that. It is erupting. And you should see the smoke that's coming out of it. You should see the ash that's coming out of it. And it might have made you wonder, what is going to be the result of all of that smoke and ash? Is it going to be beneficial at all, or is it just going to be harmful to the planet and the environment? And then here at the bottom, we watched the video about the brush fires. You should have noticed that the people were trying to flee, that the brush fires were normal, they happened, and yet it was dangerous. And that it was, I think they said 50 fires at the time that were still burning in Australia. And it might have made you think about the wildfires that have happened in California. And they happen basically every year there and the damage that they cause. And what might cause these fires? You might have thought about that. Are there humans that are causing the fires? Is it a natural occurrence? What's going on? So we're going to talk about all of those things together with our unit LS10B and C, which is long-term changes. So a couple of weeks ago, we talked about LS10A and B, and we talked about short-term changes that were daily or seasonal. And we said that a long-term change is going to be a change that has a more extended period of time that it's going to cover, years of effects. So that's what we're going to focus on today. And let's look at these 3 images that we saw. What do they have in common? Well, I just said it. I kind of ruined the spoiler. That is that these are all 3 examples of long-term changes that affect the planet Earth that are happening right now in some parts of the Earth. And we're going to talk about what each of these pictures represents specifically, but this was the polar bear. This was the body of water that was very, very green, an unnatural green. And then here is actually a tsunami under the water that we're going to talk about. So they affect our planet. They're long-term changes. They affect the ecosystem over a long period of time. And that would be for many, many years to come. They will be having an impact on the organisms that live there. So there are 3 main types of long-term changes that you need to know about in life science. So we'll talk about each of those today. Okay, so one of them is this picture of the green, yucky, yucky water. And this is called eutrophication. So eutrophication happens when you have too many nutrients that are in a body of water. So those nutrients could have come from sediment that was just ran off, like from a farm and washed into the water. It could be just poop, from too much animal poop in the water, from cows in a pasture, perhaps. that could add too many nutrients into the water. And when they get into that water, it makes the water cloudy, and as the water is cloudy, it blocks the sunlight. And when that happens, you have organisms that love this murky, nutrient rich water, and they are called algae. And once they notice that the water is all cloudy and has all these nutrients in it, the algae starts to just tell all its friends to come on in and get in here because it's great. And it makes what we call an algal bloom. So all of this green stuff here is actually algae, tiny little organisms that are just kind of so close together that they're covering the surface of the water. And we call that eutrophication. And it has lots of effects, most of which are pretty negative in an ecosystem. If you look right here, you can see that this person has dipped their hands into this eutrophied river, or it's a river here, and you can see all of this nice green guck that's all over their hands. Now, is this a body of water that you would want to swim in? Would you like to just wade in it and skip some rocks? Probably not. And just as you wouldn't like to swim there, other organisms like the fish would also not like to swim there. It would make it very difficult for them to do so. So that's some of the negative effects of eutrophication. We're going to watch a quick video about it, and then we're going to talk about that.
What is eutrophication? It's a problem that should matter to you, whether you live near the ocean or not. That's because it begins wherever people live and ends with damage to resources we all use and enjoy. It all starts when nutrients get into lakes and oceans. Remember, what's waste to humans can be food to plants and other creatures. Nutrients feed algae, like they do other plants. Algae grows and blocks sunlight. Plants die without sunlight. Eventually, the algae dies too. Bacteria digest the dead plants, using up remaining oxygen and giving off carbon dioxide. If they can't swim away, fish and other wildlife become unhealthy or die without oxygen. But it doesn't have to be this way. Protecting marine resources starts with sound agricultural and waste management practices.
So that was a quick video about eutrophication. And what you'll notice is it's a process. Okay, it's kind of a step-by-step process. You get nutrients in the water, algae loves it, algae starts to grow. As the algae grows, it blocks the sunlight. The plants that are under the water can't get enough sunlight for photosynthesis, which means they can't produce as much oxygen for the underwater animals that need to dissolve oxygen in the water. So that means that the plants and the animals both end up dying because they can't get enough of what they need. And as they die, they add even more nutrients to the water. So it's kind of like making the problem even worse. But it also said that we can help by not pouring nutrients, too many nutrients, dumping nutrients into waterways. So eutrophication is one of the 3 types of long-term changes. All right, so the next one we have would be climate change. So you should recognize this picture from the beginning and from day one. This is our polar bear that's on the ice cap, and then our warm planet that we saw that was on fire on one side. So when we talk about climate change, that means that there is a major shift. It is totally different from what's normal in the weather patterns. An example of that would be the ice age. That was a huge climatic shift. It went from being normal weather to frozen ice everywhere, right? Another example of climate change that we're currently experiencing is called global warming. And so I know you've heard this term before because we've talked about it even a little bit this year. But global warming happened when the overall temperature of the planet is warmer or hotter. The entire planet is hotter. And that is because of the greenhouse effect. We learned about that a little bit more earlier this year with the carbon cycle. And so the carbon dioxide traps the heat that's on our planet. It makes the planet warmer, makes the oceans warmer. And as the oceans heat up, It melts ice caps like the one that this polar bear is trying to hold on to, this little baby iceberg. And it also melts glaciers. And that causes all kinds of problems. For example, our polar bear here likes to have ice to rest on when it's swimming. It's a huge animal and it gets tired. And as the ice melts, it has less areas that it can rest on. So it's kind of destroying its habitat. And just as it destroys the habitat of polar bears, it could also destroy the habitat of other animals and plants. Um, and then also it causes increased storms that start over the water. So increased hurricanes and tropical storms because the ocean is so warm. There's a greater frequency of those storms that we see each year. So that is kind of climate change in a nutshell. The entire planet is warmer. And we're going to watch a quick video about that and how we can help to decrease climate change and also some of the other effects of climate change on our planet. All right, so this is our climate change video.
We've been hearing a lot about climate change, but what exactly is it? Climate describes the overall weather conditions of large
I'm going to stop it right there for a second. I would be remiss if I didn't go back to our life science student workbook and comment on the fact that we should be paying attention and taking notes right now in our life science student workbook. So let's go back here for a second to day 2 of our student workbook, and let's make sure that we are taking note of the things that we need to be paying attention to. Okay, so we're here, day 2. Here we go. So we have talked about so far eutrophication, and we have talked about what causes it to happen. We've talked about how it affects plants that live in that ecosystem and animals. And we've also spoken about how we as humans can reduce the amount. And you can also go ahead and add a sketch of, or you can clip a picture from the internet of what that looks like. Now we are discussing climate change. We have already talked about what causes it. We do know some ways that it affects plants and animals, and we're about to learn more about how we can reduce it. So this is where we are in this document. And as we watch this video, we should be looking for examples. We should be looking for how it affects plants and animals and how we can reduce it as humans. So now let's go back to our video.
geographic regions over a long period of time. Scientists have noticed a drastic change to climates over the last century. They are all warming up, from the poles to the equator to the deserts, forests, mountains, and oceans in between. Earth has gone through cycles of warming and cooling before, but this time is different. Why? Because it's not just from natural causes. Anthropogenic activity, or human action, is contributing to global warming, which is occurring 10 times faster than ever before. When we burn fossil fuels to heat and electrify our homes, drive and manufacture goods, we release tons of carbon dioxide into the atmosphere. These emissions trap heat that should escape into space, so the entire Earth gets hotter. But we enjoy warmth, so why all the fuss? It means that areas already struggling with drought have even less water and experience more dramatic consequences, like extreme wildfires. In regions fortunate to have abundant water, like high mountains, even slight increases in temperature cause the snowpack, permafrost, and glaciers to melt too quickly. Then, rivers flood, crops get saturated, and frozen soils thaw, releasing avalanches and rock slides. At the poles, ice caps melt at an alarming rate, threatening local wildlife with extinction. And as the ice caps melt into the oceans, sea levels rise, putting coastal communities around the globe at risk. Ocean warming kills corals and krill, which other marine animals depend on, upsetting the entire food chain. Warmer ocean waters also disrupt ocean current patterns, triggering extreme and life-threatening weather. Wow, this is a big deal. What can we do? We can reduce our carbon footprint. That is, find ways to use less fossil fuels. Turn off and unplug appliances when not in use. Bike, walk, or take public transportation instead of driving. If you must drive, consider an electric vehicle instead of a gas-powered one. Fix and reuse instead of purchasing newly manufactured items. Encourage friends, communities, and governments to do their part. Earth is our only home. We need to take good care of our precious planet.
Okie dokie, so that was our video on climate change. Some things that you should have noticed were some of the examples that they gave about the effects of climate change and how it can cause more flooding, more severe droughts, more storms and tropical storms. It can destroy habitats. And also, it talked about ways that we can help prevent climate change by reducing our carbon footprints, using less fossil fuels, whether we're using them in our car or we're using them to make electricity so we can conserve electricity. And that also can help to reduce the amount of carbon dioxide that we're releasing and therefore reduce greenhouse effect and climate change. So those were a couple of things. If you need to watch the video again because you missed it, then you can go back and rewind, and then you can try to catch those and put them in your student workbook. Okay, so we've talked about eutrophication, we've talked about climate change or global warming. And so the next one we're going to talk about that's a long-term change in ecosystems is what we call a catastrophic event, a catastrophe. Okay, so if you ever heard about the word catastrophe, catastrophes are normally sudden, they are severe, they are bad, they are dangerous. Okay, and so examples of catastrophic events would be a volcanic eruption, a tsunami, which is an underwater earthquake, or even the brush fires that we saw in the video that we watched on day one in Australia and the wildfires that we see in California. So catastrophic events are sudden and severe natural events that we can predict based on weather patterns a lot of times, but we cannot prevent them. We cannot stop them from happening. We cannot stop a volcano from erupting currently with the technology we have in 2020. We cannot stop a hurricane from coming. Okay. So these are known as natural disasters. Often people call them that. It can be a flood, droughts, wildfires, volcanoes, earthquakes, all qualify as catastrophic events. And catastrophic events are called natural disasters because they are part of a cycle in nature that just happens automatically. Though the greenhouse effect, as we just watched in the last video, can impact them and cause them to happen more frequently. Okay, so what are some effects of these catastrophic events? Clearly, we've seen pictures of wildfires and tornadoes and hurricanes and how they kind of just rip through an area and pull up trees, and they burn down forests, and so they destroy habitats that animals use as their homes and to get their needs met. Some organisms also die in these catastrophic events. If it's a forest fire and they can't get out quickly enough, or a tsunami and they can't get out of the way, or a volcanic eruption, that they can lose their lives. And that can be both plants and animals. Catastrophic events also can limit the resources available. There may not be as much clean water available, or water at all if it's a drought. There may not be as much clean air or oxygen available. You have smoke and everything in it. So it can also limit the needs or the resources that the animals and plants need to meet their needs. But they also can have some positive effects. So, for example, if it's a really hot forest fire It can get rid of the underbrush on the bottom of the forest to make it clean so new trees can grow. It can also open dormant seeds. There are some conifers that the only way their seeds open up is under severe temperatures. So these forest fires could actually help to open up these seeds and plant more trees. And also, if you think about a volcano, volcanoes, when they erupt, they're actually going to be helping to create new rock, which will eventually form new land. So those are benefits of catastrophic events, though they do have some negatives that we definitely see as humans because we want to live where we want to live, but they also are beneficial to our planet as well. Okay, so that was a quick rundown of catastrophic events, climate change, and eutrophication. I am going to go back to our lab sheet for just a second, our note sheet, I'm sorry. So we should have completed this top portion, and similar to what we did with the short-term changes, now let's pretend, I know it's a bad pretend, but let's pretend that there's a forest fire in Richmond. Okay, Richmond is part of a temperate deciduous forest. So there's a forest fire in Richmond, and we have lost some acres of forest land. How will this event affect each individual part of a Richmond forest ecosystem? I want you to put on your thinking caps. What do you think will happen to these organisms? What could happen to a brown bear that lived in that forest? What could happen to the entire population of brown bears that live there? What would happen to the squirrels, the cherry trees, the oak trees that were part of that forest? What might have happened to them? How might that affect the entire ecosystem? Will it affect the weather there? Will it affect the water there? Think about what you think will happen and then type it into the boxes that are shaded blue. You know, that's where you type your responses. Then at the bottom portion here, um, I gave you a description of some different events, and I want you to classify them as either an example of eutrophication, climate change, or a catastrophic event based on the notes that we took. Which one would they be qualified as? And then I want you to say, would this event be daily, seasonal, or long term? And this should be pretty easy to figure out because you know this whole section, LS10 B and C, is on long-term changes. Just a hint. Okay. So read the description and you're going to say the type of change it is, and then you'll also say whether it's going to be daily, seasonal, or long-term. The effects of it will be daily, seasonal, or long-term. And then that sets us up for our optional virtual lab for today. Okay. So we did a lab somewhat similar to this before, but this one is actually quite different. Okay, so we talked about eutrophication, and that's what this lab really is going to focus on, though we're not calling it that. And we talked about how eutrophication occurs because there are too many nutrients in the water. So in this lab, you're going to look at the coral reef abiotic factors gizmo that you can get to this gizmo through your Clever account. You log into Clever, and then you're going to search for coral reefs. And if you do that, you'll click on the one that's abiotic factors, okay? And I am going to show you that in just a second. So I'm in my Clever. I'm going to gizmos. And I am going to go ahead and look for, well, I'll do it the way that you would. Coral, right? And I just type in coral reefs. I see coral reefs 1, abiotic factor. So that's the one you need. You would click on that and you would click launch gizmo. Okay. Now we have used this gizmo before, but we did not use a certain portion of it. So we see the ocean conditions one, but what we're going to look at today is actually the land use. Okay, so you need to click on land use. And you can see 3 different types of human land use: logging, sewage, and agriculture. Any of these 3 could put excess nutrients or extra nutrients into the waterway. And so what you're going to do is design an experiment to see which of these 3 types of land use would have the greatest effect on the size of the algae population and of the coral population. So you look at the data portion of this lab to see that. So these are the species. There are 2 types of coral. You can pick which one you want to look at or only look at 2 of them. And then you have algae. And you really don't need to look at any of the other organisms because that's what we're going to focus on for this experiment, just the coral and the algae. All right, let's go back to the lab sheet. So what I'm asking you to do is to use the sliders for logging, sewage, and agriculture and design an experiment where you can test the effect of those 3 types of land use on the size of the population of algae and coral. So which one do you think will have the greatest effect? You need to identify your variables, write a hypothesis about it, and then you're going to complete the CER format, your claim, evidence, and reasoning portion of which one do you think will have the greatest effect? Why do you believe that? And then as you run your experiment, you can take screenshots and things, and you can use those as part of your evidence as to support your claim of which one you thought it was, and then reason on your final conclusion. All right, I hope that that made sense to you. And we're going to come back here. So that's what we have for today. Our last thing for today is the optional abiotic factors in the coral reef long-term change virtual lab. It's really looking at the human land use in a coral reef ecosystem. So hopefully you'll enjoy that. And then that will be it. So for today, you can finish up your activities, finish up your note sheet that you have. You can finish that portion at the bottom on long-term changes, that little worksheet, and then you can do your optional lab. And then come back on day 3 so that you can complete the long-term changes Kahoot. Hopefully you will be able to do extremely well on it. I look forward to seeing your scores. And then also you can complete the long-term changes Legends of Learning playlist, which has a couple of games and a mini quiz at the bottom to make sure that you understand these new concepts of eutrophication, climate change, and catastrophic events. So that is all we have for this week. I hope you're enjoying learning about LS10, BNC, long-term changes, and that you enjoy finishing the rest of your life science exploration for today. Thanks so much for joining me. Have a good week.